Hey students, so today we're working on the last lesson in chapter 3 and it is all about the distributive property. So in our notes, let's start with our learning target. Today it's going to say, I can apply the distributive property. So we'll start with that. And in our textbook, we should be on page 134, and that's where we'll begin. So in the last few lessons, we've talked a little bit about some different kinds of properties like commutative and associative properties. So this is the last property we're learning about in this chapter, and it gets an entire lesson all to itself because it's used in so many different aspects in math. So we'll go ahead and just write out that word distributive property. And for this one, really the point of the distributive property is to get rid of the parentheses. So the first thing we'll write underneath here is we're going to get rid of, and I'll just make the parentheses. So there's going to be parentheses involved, and we want to get those out of there and get whatever math finished is that there's inside those set of parentheses. So what we do here is we take what's on the outside of the parentheses and multiply it by everything on the inside. So we're going to write that down. It may not make sense when we write it, but when we start looking at some examples, we'll show you how it makes sense. So we're going to say take what is on the outside of the parentheses and multiply, I'm going to underline that, multiply it by everything on the inside. So as we look at our examples, it'll make a little bit more sense. So for the first one, example 1, if you look at page 134, it says using mental math. We're actually going to skip over that one. We're going to skip over example 2 as well because those two don't really get to the basis of what the distributive property is asking us to do. So we'll just write down one quick example from the very top of 134, and then we'll skip over to example 3. So at the very top of page 134 in the key idea box, there is a 3 and then parentheses 7 plus 2. Now, when kids usually see something like this, they'll go, okay, PEMDAS tells us to multiply or to do the math that's in the parentheses, which is 7 plus 2. And 7 plus 2 would be 9. And then we would take it and multiply it by this 3, so we'd have 9 times 3. Now, the distributive property is a different way of thinking about this problem. So what we would do is we would take the 3 and we would distribute it to the 7, and then we would distribute that 3 to the 2. And every time we take and put that 3 with the 7 or put the 3 with the 2, we multiply. So I call these little shoots here rainbows. So they're multiplication rainbows. So I have to take the 3 and multiply it by the 7, and I have to take the 3 and multiply it by the 2. So 3 times 7 is going to give me 21. And I see a plus sign in the parentheses, so I'm going to put a plus sign here. And if I take the 3 and times it by 2, that would give me 6. So I have just now gotten rid of these parentheses by distributing or using my multiplication rainbows. So now all I do is 21 plus 6, and that'll give me my final answer. And that would be 27. So basically, the distributive property is a way of simplifying an expression to get rid of the parentheses and possibly get a final answer. So now let's shift our eyes to page 135, and we're actually going to skip all the way to example 3. I think example 3 is a better way of identifying the distributive property versus examples 1 and 2. So we'll write down example 3. And it has an A, a B, and a C. So the main topic that we're going to be doing is something called simplifying. Now, when we simplify, we're going to take an expression and get it as short as we can. Sometimes the shortest expression is an answer. Sometimes we can't get to a final answer because there might be variables involved. So here's example 3A. They ask us to use the distributive property to simplify 4 on the outside, and then parentheses, n plus 5 on the inside. So what we're going to do is the same thing we did here. Even though there's a variable inside, we're going to solve this the same way. We're going to use our multiplication rainbows. 4 distributed to the n and 4 distributed to the 5. So these are going to be multiplication rainbows, 4 times n and 4 times 5. Well, we can do 4 times 5. We know that's going to give us 20. But we don't know what 4 times n is going to equal because n is a variable. So what we do when we have a number and a variable is we just smack them together. So we put 4 and n like that. 4 times n would be 4n. Remember, in a number and a letter together like that means multiplication. So we're going to just put them together. Now I see a plus in my question, so I'm going to put a plus in my answer. And now 4 times 5 is 20. We cannot add the 4 n's and the 20 together because 4 n's has a variable on it and 20 does not. So because they don't both have variables, or they're not both on their own like this one, we have to keep it like that. We cannot simplify any more than that. So 4n plus 20 is our final simplified answer. If we go on to question B, we have 12 on the outside, parentheses, 2y minus 3 on the inside. We're going to use our multiplication rainbows again. 12 times 2y and 12 times 3. So when we take these, remember we're multiplying. 12 times 2y's. Well, we can go 12 times 2, which is 24. And when we have a letter involved, like we did up here, we just smack that letter on our answer. So we're just going to take the y and stick it next to our 24. This time we have a subtraction sign, so we're going to put the subtraction sign in our answer. And then we have to go 12 times 3, which gives us 36. Now, since this has a y on it and this does not, we can't actually do that subtraction. So 24y, take away 36, is going to be our final simplified answer. And we have one last one for example 3. This one says 9 on the outside, and then 6 plus x plus 2 on the inside. So this time when I do my multiplication rainbows, I have to take 9 and multiply it by 6, 9 and multiply it by x, and 9 and multiply it by 2. So I have 3 rainbows to be multiplying. So my first task is 9 multiplied by 6, and that gives me 54. I see a plus sign in there, so I'm going to put a plus sign in my answer. 9 times x, we're just going to put the 9 and the x together. And then 9 times 2 is 18, and there's a plus sign in between there, so I'm going to use a plus sign in my answer. Now remember, my question says simplify. So if I look at this expression, there's a 54 here and an 18 here, and both of those numbers don't have letters on them. So I can actually take those and combine those two together. And if I take 54 and I add 18 to it, I end up with 72. So I can rewrite this as 9x plus 72 because I combined the 18 and the 54 to become 72. I can't put 9x's with the 72 because that one has an x on it. So 9x plus 72 would be my most simplified version. Go ahead and pause the video on page 135. About halfway down, you're going to see 7, 8, and 9 on your own. Go ahead and try those out. Okay, so number 7, if you try the on your own questions, is 7a plus 14. Number 8 is 3d minus 33. And number 9 is 56 minus 28d. Okay, so for our next one, example 4, this is a real-life application. So how are we going to take this distributive property and put it in our real life? The question on page 135 says, Jose is X years old. His brother, Felipe, is 2 years older than Jose. Their aunt, Maria, is 3 times as old as Felipe. Write and simplify an expression that represents Maria's age in years. So we have lots of different people going on here, and we have to write and solve an expression. So the first thing we're going to do is take out the important information. One of the people they're talking about is Jose, and they're telling us Jose is X years old. So that's important information. They also talk about a person named Felipe. And they say Felipe is 2 years older than Jose. And then the last person is Maria. And they say Maria is 3 times as old as Felipe. So what we can do here is take these sentences and kind of write little mini expressions next to them. So if Jose is X years old, what I would do for Jose is just make him an X because it says X is going to represent Jose. The next one says Felipe is 2 years older than Jose. If X is Jose and Felipe is 2 years older, we would need to increase X by 2. So we would have to take X and add 2 to that. And that would get me to Felipe. Then we have Maria. It says Maria is 3 times as old as Felipe. So if this expression represents Felipe, I have to take that and multiply it by 3. So if I take X plus 2 and put it into a set of parentheses and multiply it by 3, then I would get Maria's age. And so those are our little expressions. And so how do I find Maria? Well, Maria, her expression is 3 parentheses X plus 2. So they wanted us to write an expression for Maria and then simplify that expression. So we will go ahead and use our multiplication rainbows and distribute the 3 through the parentheses. 3 times X would give me 3X. I see a plus, so I'm going to use a plus. 3 times 2 would give me 6. I can't simplify that anymore because the x's and the 6 can't be combined. So Maria's expression simplified would be 3x plus 6. That's how old she is. Okay. There's another on your own at the top of page 136. It's number 10. You can go ahead and pause the video and try that out if you'd like. Okay, so if you tried number 10, the expression would be 5 parentheses x plus 7, and that simplified would be 5x plus 35. The next thing we'll do on page 136, there's one more vocabulary term that we need to talk about, and it is something called like terms. We've actually already been talking about like terms in this lesson without actually naming it. So it says, in an algebraic expression, like terms are terms that have the same variables raised to the same exponents. Constant terms are also like terms. So if you have something like what they have here, 5x plus 19 plus 2x plus 2, we're going to circle some like terms. So this 5 has an x on it. So if we look at this list of numbers, there's another number with an x on it, and that's 2x. These two would be like terms. So I could combine these two together because they're like terms. They both have the same variable on them. And if we look at the number 19 and 2, those are also like terms because they both do not have any variables on them. So I could combine those two because they are like terms. So like terms, they look alike, and they have the same variables. Or no variables for these two. So they look alike, and you can only combine them if they are like terms. So example 5, which is the last example of the lesson, is going to ask us to combine some like terms. So we're going to have to identify, are there any like terms in the question? And then if there are, we're going to go ahead and combine those. So let's put example 5. And they want us to simplify. So we're trying again to try and get it as short as we can. There are a few questions here. So simplifying question A. Question A says 3x plus 9 plus 2x minus 5. So let's first circle some like terms. So we have a 3x here, and we have a 2x here. So 3x's, and then it says plus 2x's would give us 5x's. So those two combined would be 5x's. Another set of like terms would be 9 and 5. So if I were to just take these two out of the expression, it would say 9 take away 5. If I were to take 3x's and 2x's out, it would be 3x's plus 2x's. I'm using the sign that's directly in front of the second item. So since there's a plus in front of the 2x's, I use the plus. The second item here would be a 5. There's a minus in front of that 5, so that's why I'm using a minus. So 9 take away 5 gives me 4. So I have a positive 4 and a positive 5x's. So my simplified version would be 5x's plus 4. The reason I don't just bring down this minus sign is because when I did that math, when I did the actual math, 9 take away 5, I got a positive 4. If I get a minus there, that means I have a negative number that I ended with, and we're not into negatives quite yet. The next one is y plus y plus y. They want us to combine like terms here or simplify this expression. Well, y is a like term with y, and it's another like term with this y. So they're all like terms. This is, remember, 1y. Remember, there's a hidden 1 in front of each of these. So if I take 1y, add another 1, and add another 1, I end up with 3 y's. And I can't do anything more than that, so that's going to be my simplified version. Question C, they want us to simplify 7z's plus 2 parentheses, z minus 5y. This has quite a bit going on here. The first thing we need to do is use the distributive property that we learned earlier today. And we're going to take this 2 and distribute it through the parentheses using our multiplication rainbows. So 2 times z would be 2z. I see a minus here, so I'm going to put a minus in my answer. 2 times 5y's. 2 times 5 would give me 10. And then remember, when there's a letter involved, you just have to knock that on your answer. So I've just gotten rid of these parentheses, and now I have 2z minus 10y. I still have this 7z. It didn't change, and I still have this plus sign. That didn't change either. So I've just started my simplifying by doing the distributive property. Now I can look and find some like terms. So there is 7z's right here, and I see another number with a z on it. So those two are like terms. 10 has a y on it. Even though there's a letter on it, it's not a z. So we cannot circle the 10 y's. It's not going to be a like term. So 7z's plus 2z's would give me 9z. Oops. And then I have a minus sign, and I have 10 y's. I can't do anything else because z's and y's are not the same variable. So that is my most simplified version of that expression. You can pause the video and try numbers 11 and 12 at the bottom of page 136. Those are the on your owns. Okay, if you tried 11 and 12, number 11 is 8 plus 2z, and number 12 is 4b plus 17 in their most simplified versions. Okay, and that brings us to the end of our last lesson in Chapter 3.